Hello, everyone, and welcome to the last part of this remote learning. Hopefully, you guys are doing well, staying safe, staying healthy, and hopefully, you're ready for school year to be over. So, I'm going to go over in this video the multiple choice questions, and I'm also going to post when I post this video, I'm going to post the key for the free response questions. So, good luck, and I guess I'll see you guys hopefully sometime when you're college students. All right, here we go. So in number one, we're asked to find a 95% confidence interval for the slope of this regression line. So the moment I see that it's asking for a linear regression t interval for the slope, I immediately circle the slope. All right. And in this case, it's 1.054. It's always going to be that number that's first next to the variable that's not listed as intercept or constant. So the key thing I always look for is wherever it says intercept or constant, I'm ignoring that and only really looking at this row. Okay? Now, for a confidence interval, we have our statistic, the 1.054, plus or minus the margin of error. And the margin of error is your critical value, so t star, times the standard error of your statistic, in this case, b bar, which is the slope. All right, now they've already given us the standard error. It's to the it's right next to our slope, so it's going to be plus or minus, I don't know t star yet, times 0.322. Now, the reason I put this as the number one question is because this is one of the most common mistakes that I see every year, and I'm going to ask it on the test, is a lot of students think, oh, okay, I'm looking for a t star. Well, look at this. They give me a t value. It's right here. But that is not t star, okay? That is the t test statistic value, which then would give you a p value to the right of that. That's what you would use in the output if you were being asked to run a linear regression test, all right, to see if there was an association, a linear association. But we're not being asked to do that. So we actually have to go to a link, which again, you will have posted to you, so you'll know all these links will be given to you to find the t star. Before I go there, I want to make sure that I know my degrees of freedom, which for linear regression t-tests and for t-intervals is always the sample size minus 2. So in this case, it's 31 trees minus 2, which is 29 for the degrees of freedom. And then because I'm doing a confidence interval, I need to type in how much area to the left or to the right. It's your choice. So for 95% confidence, if I split the remaining percentage of 5%, that means I have 2.5% below my critical value. And if I went to the upper one, 2.5% to the right. So you can use either one. You'll see on the link. Either one is fine. My preference is to use to the left. Okay, so we have the student's t. All right, this is going to be given to you. I know the degrees of freedom is 29, and I'm going to the left, but you can do to the right. It doesn't matter. And the area under the curve is 0.025. To get the t star, make sure you click the blue box here to get 2.04523. 2.04523. So that is my t star, 2.04523. Okay, now to finish the problem, all we're going to do is multiply our t star, which we just found, of 2.04523, times our standard error of 0.322 to get 0.659. Okay, so to find the answer, I'm going to take 1.054 minus 0.659 and get 0.395, and then 1.045 plus 0.659 to get 1.713. So I look for the answer that's closest to that, and it looks like the answer that's closest to that is B. All right, with rounding. All right, so again, that is there's a lot going on in that, but just as a reminder, you get to use your notes on all these assessments, all these questions, so you can literally watch the video as you're taking the test. It's all open notes, open video. All right, so that's number one. All right, let's keep going. Number two. Now, number two is giving you a two-way table, and it says, what is the contribution to the chi-square test statistic? So chi-square test statistic would be that simple. For the men who selected business networking as the most important factor. So that's 45 responses in this table. Now, there's really two ways to do this, and I'm going to show you both ways. All right, the first thing I'm asking myself is, okay, if I'm trying to find a chi-squared test statistic, I want to use those links that are provided. I need to figure out which test am I doing. Now, if you think back to chi-squared, we had three different types of chi-squared tests. We had goodness of fit, we had homogeneity, and independence. The fact that this is a two-way table, right? This table right here is called a two-way table because you have two variables. You've got the factor and you've got their sex. So ultimately, you're looking at eliminating goodness of fit because goodness of fit will not have two-way tables. Okay, so the moment I see a two-way table, it's got to be homogeneity or independence. Now, it doesn't mention anything about if there's a relationship between the two, and you'll notice it doesn't really matter in the work you're going to do because it's not asking for any type of, it's not like a free response question asking you to show your work. So really what I was trying to help you narrow it down to is that it is not going to be goodness of fit. And I know it's been a while, but the links that I share with you for chi-squared, the link for homogeneity and independence is actually identical. So the work we're going to do here is actually the same whether you thought this was a test for homogeneity or a test for independence. So I'm going to type in my categories. I know this one is men and women. For the columns, we've got personal friend. There we go. Thank you. We have stay in touch. We have mutual friends, business networking. Oh, too many Ks. And then finally, other. Okay, and then we're going to hit next. Now I'll be able to actually type in the observed values. I'm just literally typing these in from the problem. So 600 men, said personal friend, then 210, then 105, then the one I care about, 45, then 40. For women was 650, then we had 224, 65, the last two, 15 and 46. Okay, so again, just take your time. There's no rush on this. There's no, I mean, obviously there will be a due date, but it's like many days. So take your time. And once you have them all in, you're gonna hit next. Now it's gonna ask you, in this case, for a significance level. You're not actually, in this problem, being asked to find like, or make a decision about a p-value compared to an alpha level or a significance level. So it doesn't really matter here. You can hit calculate chi-squared. Now it's been a while since you've looked at this probably, but when you're looking at this, I'm looking for men and business networking, which is this cell here. So 45, the first number, is the observed value. That's how many men said they would use it for business networking. Then the in parentheses is the expected value based on the totals. And then finally in the brackets is the actual number I want, the chi-squared statistic for that individual cell, right? If we're doing this for a test, we would actually look at the entire chi-squared statistic, which takes all of them from each cell and adds them together. But in this case, it just wants the men who chose business networking. So 7.5 is our answer. Okay, so 7.5 is our answer. Come on. You can do it. There you are. Where is it? Number 2. Come on. Of course, that's the one. There, it's trying. Anyway, the answer is 7.5 whenever it returns. There it is. Good job. Okay, now let me show you the other way that you could do this, right? So the other way, and I'm not saying you have to do it this way, and I'll be honest with you, since I have the link, I've got open notes, I got videos, I'm not going to do it this way. This way requires more work, but I'll show it. Go ahead and show it to you. If you ever want to find the expected values for any cell in a two-way table, you can always use, and this is in one of my earlier videos, you can always use this quick way of doing, it's not really quick, but you would do row total times column total divided by grand total. And since they're only asking us to find a chi-squared value for one cell, this work won't take as long because it's just one cell. If you're doing this for all of the cells, it then becomes very tedious. So the row total would be this number. The column total would be this number. All right, you can add all those numbers up in your calculator, or you can just go back. Obviously, if you've done this, you won't need this, but I'll just use it since it's here. 1,000 total men and 60 total people said business networking. So the row total is 1,000. So that's 1,000. And the column total was 60. That one's a little easier to see. Divided by the grand total of 2,000. Right? 1,000 men, 1,000 women. Okay? So if you do that, obviously you already know what the answer is for this expected value, but if you do 1,000 times 60 divided by 2,000, you'll get 30. So we're saying the expected value is 30. Okay? Now to find the chi-squared value using our formula from chi-squared, it is going to be observed minus expected squared, right? We've got to square it in case it's a negative, divided by expected. So for the men who said business networking, it's going to be 45 minus 30 squared divided by 30. So if you do a little bit more work, that's 15 squared, which is going to be 225. And 225 divided by 30 is, you guessed it, 7.5. Right? So again, you get the same answer, a little bit more work in terms of what you'd have to do for the arithmetic, but ultimately, your choice, whatever you find easiest, using the website or actually doing the math yourself. All right, so that's number 2, 7.5. Okay, number 3. Okay, so number 3 is asking us to find a p-value. Approximately what is the probability that the observed responses would be as far or farther from the expected responses if there is no association between age group and preference? Okay, so this is asking us to use one of our links to find the p-value. Okay, so the first thing I ask myself is, okay, well, this test that I'm being asked to do in terms of like the content has chi-square tests, which are about categorical variables, and linear regression, t-tests and intervals, which are about quantitative variables. So when I'm thinking about this, they're being asked which mayoral candidates they have a preference for, and they're selecting their age. So even though age, you think, oh, it's a number, it's quantitative, they're putting them into 3 categories for age, right? 3 age groups. So they're making it into a category. And when you're just choosing a mayor, your preference for mayor, that is not quantitative. So this is categorical. And ultimately, that means we're using chi-squared. Okay? So this value here, the test statistic, our chi-squared, let's try again, that was abysmal. Our chi-squared is 3.7408. So now you're ready to actually, well, you're almost ready to use the link I'm going to show you, but you're going to see the link is going to require degrees of freedom. So what I did mentally, and I'm going to draw it out for you, is I thought, okay, well, they've got 2 variables here, right? They've got 3 age groups. So I've got age group 1, age group 2, and age group 3. Let me do that again for you. So age group 1, age group 2, and then below it, age group 3, right? So 1, 2, 3. That's 3 rows. And then for the categories, they're picking one of 2 mayors. So in this one, they've got mayor 1, or candidate 1, I guess I should have said, and mayor candidate 2. So when you find the degrees of freedom, it's always going to be rows minus 1 times columns minus 1. And that order doesn't matter. You can write columns minus 1 times rows minus 1. It's multiplication, so commutative, it doesn't matter. What matters is we have 3 rows and 2 columns. So if you use that formula for degrees of freedom of 3 minus 1 is 2, 2 minus 1 is 1, 2 times 1 is 2. So 2 degrees of freedom. So I'm going to go to the link now with this information of chi-squared is 3.7408 and degrees of freedom is 2. So I'm going to use my chi-squared distribution this time. Degrees of freedom 2, and my test statistic was 3.7408, I believe. Click the pink box to get our p-value of 0.1541. So I'm looking for the answer of 0.1541 for the p-value. So let's see what we got. 0.1541 looks like letter B. All right. All right, let's go to number 4. Number 4 is asking for another confidence interval. This time, though, it's 98% confidence for the slope. So again, the first thing I see in my computer output is we have a constant. Don't care about that. Care about the one that doesn't say constant or intercept, which is blood sugar. So here's my slope. 0.161 is going to start our confidence interval. So immediately I can cross out A and B. All right, they are not using the correct slope. Plus or minus, they're using the intercept. Plus or minus. This is where it's going to be our T star times the standard error of our statistic or our slope. Okay, and they've given that to us. So 0.161 plus or minus, I don't know, T star, times 0.073. All right, that's that there. Okay, so it looks like that didn't help me with C, D, and E because they all have the same standard error. Makes sense. So really this question comes down to, do I know how to find our T critical value? All right, and again, that requires 2 things. Number 1, it requires what are you going to type in for the area under the curve? We have 98% for our confidence level. So you're splitting 2% in half, so that's 1% or 0.01 in each tail. All right, and then for degrees of freedom, this is talking about a linear regression T interval for a slope. So the degrees of freedom is sample size minus 2, which in this case, 22 observations minus 2 is 20. All right, so armed with that information, I can go to my link. Again, I'm using the T distribution. So I'm going to go back here, put in my degrees of freedom of 20. All right, I'm going to go ahead and delete that out. I still have the lesson in there, which is what I want, but now I'm doing 1% and clicking the blue. 2.528. 2.528 is what I'm going to write down. 2.528 is my T star. And if you look at your answer choices, the only one that matches that is C, 2.528. All right, so that is number 4. Again, awfully similar to number 1, right? I'm trying to make my point here that you need to know how to do this. Okay, number 5. All right, so we're looking at which of the following tests could be used to determine whether the proportions of service requests classified into the 10 service categories for the town differ from the national proportions. Now, immediately, you can look at this and see, okay, this question is asking you about tests that we did in a previous unit, right? The 2 sample t-test for difference of means was from the last test. Same with the matched pairs t-test, okay? And this is actually not talking about means. It's talking about publishing proportions, all right? And they're asking for requests, and then they're classifying them into 10 categories. So this is categorical, so this is chi-squared. I don't know, we've never talked about a t-test for correlation of proportions. Don't know what that is. Okay, so it really comes down to, do you think this is chi-squared test of independence? That's what this is here. Or is it a goodness of fit? Now, if it was independence, it would say something about, Do you think that there is an association or a relationship, or it might even use the word independence? It doesn't say anything about that. It's literally just asking, do we think the proportions that we get back in our service requests are going to be the same or different from the national proportions? So basically, do they fit what it would look like for the nation? So that means this is going to be a goodness of fit test. All right, number 6. Now, number 6 is asking you to find the appropriate test statistic. Now, I'll be honest with you, this isn't really going to be on the test, but I wanted to just show you of how you can do this. We've talked about test statistics being our statistic minus our parameter divided by the standard deviation. Okay, now to kind of make this mean something to you, all right, our statistic for this is about the slope. So we have our B bar, which is our sample slope, minus our parameter. In this case, it would be that beta, which you remember from the linear t-test, divided by, we're not going to know the standard deviation, so we're actually going to find the standard error of B bar. All right, now it's telling us a couple of things. Number one, we know from the computer output up here, again, I only ever care about the row that has a variable name other than constant or intercept. So this is the only row I care about. So my B bar is negative 2.20 minus, it says we're testing to see, comparing it to a slope of 0. So no slope would mean no relationship. So beta is 0. And then here's where it gets a little tricky. Standard error, right? The formula for standard error that we've used many times, in this case for a mean, would be the standard deviation from the population, so beta, over the square root of the sample size, okay? But what they're trying to do and trick you here is they're trying to get you to pick E. Okay, they're trying to get you to pick this one by taking the standard error and dividing it by the square root of 11. Right? But the thing is, guys, is that you're dividing by the standard error. They gave you the standard error. So just write the standard error. They've already done that division of the radicals. So you don't have to do it again, right? That would not be correct. So this is what I'm looking for in my answer. Again, not really on the test, but I wanted to show you how they're using a lot of this computer output to make you do stuff that you've seen before. Okay? So the answer is going to be D. All right. Number 7. Now, number 7 is another one where they're giving you a bunch of information. You've got to choose which test. Now, the moment I see a two-way table, right, this is categorical data in this two-way table, talking about the car or truck, so vehicle type, and then your vehicle color. Those are categorical variables. So I'm going to cross out the two-sample t-test, two-sample z-test, a match pairs t-test, because those are all for, I guess the A and C are for means, and the two-sample z-test would be for proportions. I'm not doing proportions here. So it really comes down to, is this a chi-squared goodness of fit test or a test of independence? There's really two ways to think of this. Number one, this is a two-way table. And I told you guys with an earlier problem, the moment I see a two-way table, I know that it's not going to be goodness of fit. Okay? So the fact that this is a two-way table means that this is not goodness of fit. So the answer is independence. The other way you can see is in the question it says, which of these is most appropriate to see if there is a relationship, right? I told you guys, they're going to say that word, relationship, association, independence. They're going to use a word that will tell you it's going to be independence, and that's what's happening here. Okay, number 8. Now, number 8 is asking us to do another confidence interval. You're going to get tired of these, I'm sure. So in this case, 95% confidence interval for the slope. So the moment I see that, I'm going, all right, let's get the slope. Well, here's the slope. It's 0.583. Now that didn't help me because all the answer choices have 0.583. Plus or minus, I don't know, t star times the standard error of our slope. The standard error is right next to it. So I know that's going to be 0.138. So I'm going to go ahead and cross out the ones that don't have, times 0.138. So that's C, D, and E. Wow, look at that. I haven't done anything else besides write down what they've given me, and I've made it 50-50. So now I need two things to find T star. It's the third time we've done this. You know it's going to be on the test. This is 95% confidence. So I'm splitting 5% to get 2.5% in each tail. Your choice if you want to do upper or lower. And then degrees of freedom is sample size minus 2. In this case, let's see, the sample size and the problem says 23 students. So minus 2, degrees of freedom is 21. All right, so I've got that. I'm going to go to my link with that information to find T star. So here we go. All right, make sure you use the correct one. We're on T distribution. So we said 21 degrees of freedom. Let's go and delete that. To the area to the left for me is 0.025 for 2.5%. Click the blue. You get 2.07. The 9's going to round, so 2.08. 2.08. So I'm looking for the answer. 2.08. And there it is. 2.080. So the answer is B. All right, again, we've done that. It's the third time now. Okay, number 9. Number 9, I almost didn't put it in here, but we did talk about doing linear regression tests and talking about the assumptions and conditions. And one of those is just making sure that you check the residuals plot when you're looking at the scatter plot to see if there is a linear relationship or to see if it's appropriate to even use the linear model. So in this case, I'm just kind of seeing if you remember anything about residual plots. If these are all residual plots, and we want to find the one that would say that is an appropriate model for the data. All right, so we're looking, in this case, for nothing to be in the residual plot. So I'm looking for a cloud of dots, right? This one has a curve, that one has a distinct pattern. These two have what we call fan shapes, where they're getting kind of tapering at the end or the beginning. So the only one that shows a distinct cloud or no pattern is C. That's really, I'm not necessarily going to say it's on or not on the test, but in this case, I'm looking at testing you about, do you remember residual plots? Okay, number 10. All right, last one. Look at that, another confidence interval. All right, now this one is a little different. All right, it's talking about a 95% confidence interval for the slope. So I went ahead and wrote down my slope of 2.697, but you'll notice it's just asking for the margin of error. Right? None of these answer choices even talk about the statistic. So I don't really need the 2.697. I need the margin of error, which is T star times the standard error of our statistic. So in this case, I don't know T star, but I do know standard error. It's right next to our statistic of 0.745. Now, I thought this one would have been just a little too simple for the test because all of the answer choices A through E have the same exact T star. So you didn't actually have to go in to the link and figure out what it is. They're all the same. So the only thing that's going to tell me the answer is which one just has 0.745 as the standard error. And if you look, B is incorrectly divided by the square root of the sample size. This one is, I don't even know what 5.505 is. This one is taking that number and divided by the square root of the sample size. And this one is using the incorrectly the slope. So the only one that has just the standard error is A. Okay, so hopefully you'll get a chance to watch this, and you can watch it as many times as you want. You can watch it as you're taking the test. Hopefully this is helpful, especially in terms of the links that I used and my thought process, and hopefully you'll be very successful on the test. Good luck.